Welcome, everyone, to the 2025-2026 Speaker Series hosted by the Forum for Equity in Elementary Mathematics. I am Annie Sussman, your host for this evening. We'd like you to know that today's webinar is being recorded so it can be posted and shared on the Forum website. We would also like you to know that we have reserved some time at the end of the presentation for questions. You can submit questions throughout the session via the chat box to Megan Murray. Before we begin the presentation, I'd like to introduce you to the forum. The Forum for Equity in Elementary Mathematics is a web-based resource hosted at Turk in Cambridge, Massachusetts. Turk is a nonprofit organization whose mission is to improve math and science education. As part of its mission, Turk is committed to modeling how diversity, equity, and belonging can improve STEM education and research practices in order to create and support inclusive learning environments and equitable outcomes for all. The forum was launched 2 years ago as an online free resource to support educators who are thinking about equity, access, identity, and agency in the elementary mathematics classroom. The speaker series is one of the ways the forum brings together educators to share work, ideas, and perspectives related to these critical topics. Last year's series, Elements of Equitable Math Learning Communities, focused on 4 key areas that support equitable teaching and learning. These areas are outlined in a framework we developed for educators, which is available on the forum website, as are recordings of each of those talks. This year, we're centering the series on students, who they are as math learners, and the experiences they bring to the classroom. We want to look closely at how students make sense of mathematical ideas and how their backgrounds and interests shape that learning. Today's session presents research-based recommendations for effective and equitable mathematics instruction for multilingual learners. It is an honor to introduce today's speaker, Dr. Judit Moschkovich. Dr. Moschkovich is Distinguished Professor Emerita of Mathematics Education in the Education Department at the University of California, Santa Cruz. Her research has documented the assets bilingual Latina students use during classroom mathematical discussions. She is a member of the National Academy of Education and a fellow of the American Educational Research Association. Originally from Argentina, she came to the U.S. at age 14. Spanish is her first language. So please join me in welcoming Dr. Judit Moschkovich.
Hello, everybody. I am going to start sharing my screen. All right, everything looks good. Welcome. I am talking to you from Santa Cruz, California, unceded territory of the Ama Mutsun. I want to thank the organizers for this invitation and, of course, all my mentors, colleagues, and especially the students and teachers I've worked with. My work is focused on how adolescents learn algebra. I principally work with adolescent bilingual math learners. I look at classroom discussions and the relationship between language and learning mathematics. My training and area of expertise are in mathematical thinking and learning. I'm not an expert in linguistics, bilingual education, or language acquisition, but I talk and listen to those people because they've taught me everything I know, sometimes about my own bilingualism. So although I'm an English learner myself and Spanish is my first language, I depend on those experts in bilingualism and sociolinguistics for insights and research on language. And you'll hear some of their work in the talk that I will be doing today. So to give you an overview, first I'm going to give you a quick summary of what I've collected as research evidence for effective math instruction, which might be really familiar to you, and effective math instruction for multilingual learners, which might not be as familiar to you. And then what I'll talk about is the intersection of where those two intersect. I will illustrate those recommendations with a video clip. I'm going to ask you to watch the clip 2 times and to put some responses in the chat 2 times. And then I will share with you my analysis of the example. and there'll be time for Q&A also. So to start with, I want to share my definition of equitable math instruction because we talk about equity and equitable a lot, but I wanted to make sure up front to share how I've written about equitable math instruction. So I define it as increasing participation, success, and achievement from students from non-dominant communities. That covers a lot of students in a lot of communities. Supporting mathematical reasoning and math practices. You'll hear much more about math practices as I continue. And providing opportunities for students to use multiple resources and to participate in multiple math practices. In general, what we want to do is treat language as a resource, not a deficit. We want to emphasize academic achievement, not only learning English, but also learning mathematics. And we want to honor student resources. Those would be the practices that are common among students who are bilingual or who use non-dominant language varieties. So what are some of the research-based recommendations for effective math teaching? This is a really, really quick summary of 50 years of research. I feel like, because I've been around for a while, we keep repeating these, but they're important and good to repeat and good to clarify. So the first recommendation is that teachers and students attend to concepts and that teachers give students time to wrestle with important math. Some people call that productive struggle. Another recommendation is to maintain high cognitive demand, not quick answers, not just simply calculations. So focusing on reasoning and having students explain and justify their reasoning. And we've settled sort of debates around, is it conceptual understanding or procedural fluency? We want to balance those. Now, focusing on conceptual understanding takes more time. So balancing doesn't mean that you spend 50-50 time on both of those. Sometimes conceptual understanding lessons take a little bit more time. And I want to make one clarification that concepts are not definitions that students memorize. It's an easy way to misunderstand what a concept is. I have lots of examples of conceptual understanding, but one of my favorite ones is connecting representations. For example, showing the meaning of 7 times 8 using an area model can show conceptual understanding. And you can put something else in there instead of 7 times 8, a half times a third using an area model also shows conceptual understanding. It took me a long time to realize that one of the reasons in math education that we're obsessed with connecting representations is partly because it's a way to show, support, and develop conceptual understanding. So I came up with the Venn diagram. This is as much as my illustrations, it's complicated as my illustrations get. Effective research-based math teaching, focusing on conceptual understanding, attending to concepts, time to wrestle with important mathematics, high cognitive demand, explain and justify. Because then I also want to bring in the first important thing to do is to teach math for understanding. What are students doing when we're focusing on understanding? They're doing more than procedures or memorizing. They're using and connecting multiple representations. They're showing and describing meaning for symbols. And they're sharing, refining, and critiquing their and each other's reasonings. That means they're using language to do math, whether it's spoken or written. And they're engaging in what we now call math practices. Now, math practices existed before the Common Core, but they're also based on the Common Core. I can't remember 8 of them, so I only remember 4. I also disagree with 1 or 2 of the ones that are in the list of 8. I've picked my favorite ones here. I emphasize making sense of problems and persevering in solving them, reasoning abstractly and quantitatively, constructing and communicating arguments, and looking for, making use, and expressing structure or regularity. Now, before the Common Core, you could also just focus on reasoning and communicating because that's what they were called in previous documents. And that's okay. If you hear those words, these are also the mathematical practices that are valued by the communities of people who use mathematics to do things in the world. So I want to add to that diagram, to conceptual understanding, also math practices. So now shifting to what are the research-based recommendations to support academic success for English learners? And I haven't changed the slide. It should say multilingual learners instead of English learners. The first is high expectations and no deficit models. We want to have the instruction be based on rigorous standard-based curriculum. That means we don't change the curriculum just because we're working with multilingual learners. Instead, we provide support and accommodations. Teachers need to reject the deficit models of students and hold high expectations for all students. We can provide additional time and instruction, but not lower the expectations. The second one is to treat language as a resource, not a deficit. There's a history in mathematics education of treating everyday language as an obstacle, as if it gets in the way of doing mathematics. And I've written a lot about how everyday language is used even by mathematicians and physicists to express very mathematical ideas. So everyday language is not an obstacle and it's not a resource. And home languages are not an obstacle or a resource. I'll give you some examples of that when we look at the video. I did want you to notice that we've known these things for a very long time. These come from 1995. So these are, again, research-based recommendations that have been around for quite a while. Then people who are working with multilingual learners also say that we need to provide abundant and diverse opportunities for speaking, listening, reading, and writing. And we need to encourage students to take risks, construct meaning, and seek reinterpretations of knowledge. Now, those words in blue are the words that people who work in second language acquisition use. What do we call those in math education? Communication, right? Speaking, listening, reading, and writing. And conceptual understanding, meaning, or reasoning for the second one. So this is good news in that there's some things that will overlap. So for academic success for English learners or multilingual learners, again, communication, meaning, understanding, or reasoning are also there. No deficit models, high expectations. Notice that I mentioned multiple modes: speaking, listening, reading, writing, and then we would add graphing, drawing. And I'll say a little bit about language and cultural resources that might be specific to our multilingual learners. The good news is that there's an intersection, so that as you're teaching math, you don't have to do everything new when you're working with multilingual learners. There are some things that in the intersection, all students need and multilingual learners need. Now I'm going to talk a little bit more about what it looks like specifically when working with multilingual learners. So conceptual understanding, math practices, reasoning, and communicating are absolutely in that intersection. So students need to have opportunities to use multiple resources. I'm going to keep repeating this, not just listening, but also speaking, reading, writing, and we would add drawing and graphing, using multiple representations, drawing, gestures, objects, and symbols. And this is an idea that came from Beth Herbel-Eisenman. She talks about communication settings. The ways we use language changes when I'm working alone, I'm talking to myself or writing to myself. When we're working in pairs or small groups, we tend to be informal and we'll say, look at this and look at that, without saying really what it is that we're looking at. And it's very different when it's a teacher-led discussion. So different settings are important. There are some resources that are specific to multilingual learners. So for cultural resources, some examples would be invented algorithms that might look different. If students are coming from different countries and their parents are showing them different algorithms. Alternative notation, my favorite example is the symbol for long division, which looks one way in Latin America and the other way in the rest of the world. And it is really just a symbol, but it does confuse, and it confused me, continues to confuse me. I can't tell you which one goes with which country. There's also the decimal comma is a decimal point elsewhere. These are just symbols. However, it means that those of us who are living in two communities have to switch amongst those. And we might feel either less confident or look a little confused, but it's really not about the mathematical ideas, right? It's just the notation looks different. And of course, community activities are also a cultural resource. For linguistic or language resources, both everyday and home language are resources. One example would be cognates in Spanish. Those are words that sound similar in Spanish and in English. So for example, in terms of math terms and geometry, many of them will come from Latin. And so we can better support Spanish speakers understanding of formal mathematical vocabulary if we use words like translation and rotation instead of saying something colloquial like flip. So those are times when, again, knowing something about the home language can help. It doesn't help with all home languages, but specifically, this would be an example for Spanish. Now, to know whether particular resources such as vocabulary in a first language, alternative notation, or algorithms are actually a part of your students' repertoires, teachers need to know the details of the history of their students' academic instruction in math. The biggest question is, did they have any math instruction in their home language? Are their parents working with them in their home language? Is a grandparent working with them? Is a friend or a neighbor working with them? If not, do not expect them to know any math vocabulary because there's no place where they would have been learning that math vocabulary. So some people at this point will say, or may wonder, well, isn't that just good math teaching? Here's how I think about that question, because I think it's a really important question. In math instruction, there are some things that are important for all students. Teaching math for understanding, connecting multiple representations, focusing on student reasoning, explaining why, not only sharing the answers, and multiple modes. There are some things these are the things that are important for all students. And then there's some things that are essential for multilingual learners. Multilingual learners need more than talk or text. They have to have multiple representations and multiple modes. So another thing that is important for multilingual learners is more than whole class teacher-led discussions. We focus on those a lot, and multilingual learners need to have what, again, Beth Herbal-Eisenman calls multiple communication settings. So one way to do this is to have a cycle where you get some time to write responses alone, then you do some pair work, then you do small group work, and then you have whole class discussion or presentation. I've often been in classrooms where teachers say, I can't get my multilingual learners or my students who are learning English to talk in a whole class discussion. So what we need to do basically is scaffold that participation and not expect students to jump in and come in and share their thoughts. So to scaffold participation in discussions or presentations, provide the multilingual learners with opportunities to, again, think alone, prepare, share with their peers, review what they've done, this is really important, and practice. In terms of how to support mathematical discussions, I'll advertise or plug here how to support the 5 practices for orchestrating productive math discussions. The example we're going to look at today, there's 5 practices here, focuses on the second practice, which is monitoring students' responses to tasks, which is also another way to use the strengths and the assets that students bring. That's why I focus on that second practice for orchestrating productive discussions. So let me tell you a little bit about the classroom example. This will help to ground 2 recommendations for instruction to support multilingual learners in math classrooms. The lesson excerpt comes from a 3rd grade bilingual classroom in an urban California school. In this classroom, there were about 33 students. identified at the time the label was limited English proficiency. In general, this teacher introduced students to topics in Spanish and then later conducted lessons in English. The teacher themselves was bilingual again and worked in both Spanish and English. The students had been working on a unit on two-dimensional geometric figures, and for several weeks, instruction had included vocabulary such as radius, diameter, congruent, and the names of different quadrilaterals in both Spanish and in English. Students had been talking about shapes, and the teacher had asked them to point, touch, and identify different shapes. This lesson was identified by the teacher as an English as a second language math lesson, one where the students were using only English in the context of folding and cutting to make tangram pieces. So they had tangram pieces in front of them on the tables. So this would be a good time to open the PDF handout, and I'll give you a few minutes to consider the question the teacher asked. Who can describe a rectangle? So I'd like you to take a few minutes to describe a rectangle. If you're sitting next to somebody, share a description with the person next to you. If you're alone, then write down a few descriptions. And I'll let you know when about a minute or two has gone by. And that's about a minute. Take about another 30 seconds. Again, the goal of this is just to give you an idea of what the students will be responding to. So you've had a little time to think about what they're doing, what they're thinking about. All right, so I'm going to ask you to watch the video for the first time and do a notice what do you notice and what do you wonder. Listen carefully, there will be subtitles, and you're going to watch Julian, which is one of the children at the table. And I think we'll open up the chat so that you can put your responses in the chat and we'll be able to see them. And at the beginning of the video, it's quiet, so don't worry if you can't hear. But if by the time that the teacher's speaking you can't hear, please let us know. We check the sound, but you never know. So again, what do you notice? What do you wonder?
Okay, today we are going to have a very special lesson in which, boy, you're really going to have to listen. You're going to put on your best listening ears, because I'm only going to speak English. Speak anything else, only English. Let's see how much we remembered from Monday. Hold up your rectangle high as you can. Okay, good. Now, who can describe a rectangle for me? Eric, can you describe it? Can you tell me about it?
A rectangle has two short sides and two long sides.
Two short sides and two long sides. Can somebody tell me something else about this rectangle? If somebody didn't know what it looked like, how would you say it?
Parallel.
It's parallel. Very interesting word. What does parallel mean?
Parallel.
Wow, that's a pretty different word, isn't it? Parallel. Can you describe what that is?
never get together. No. They never get together.
Okay, what never gets together?
The parallel, they when they get all the they go higher. They never get together. Yeah.
Interesting, isn't it? Very interesting. So that means if it's a rectangle, then the sides will never meet. Those sides will be parallel. Good work. Excellent work. Anybody else have a different idea that can tell?
All right, so please, anything that you're noticing or wondering about? And I'll read the chat out loud because that sometimes helps. Somebody noticed that the teacher repeated the student's word. There was a murmur of surprise when the teacher announced teaching in English. The teacher probed for more information. What do you mean by get together? The student had a model in front of them to help describe his definition of parallel. The teacher used gestures while speaking. Anything else? Everyone has a rectangle to hold and point to while talking. So again, there's multiple representations. The first child sounded confident. At least one student was using gestures. Great thing to wonder. How does he know the word parallel? And the second response from a child may have been from two students. Couple more? Were students sitting in rows? They were sitting at tables of 4, so 2 on each side, and Julian and his partner were sitting on one side. The student drew out his idea for parallel while sharing, again with his fingers. And somebody wondered if they were sitting in rows, okay? All right. Well, watching a video once is not enough, so we're going to watch it again. I would like to see how many students held their rectangles up at the beginning. I think the camera showed us what they could. They only had one camera that day in the classroom. So I'd like you to watch the video again a second time. Continue to notice and wonder, because that's what we always do. Sometimes people wonder why it was only speaking English, but I want to make sure you know this is a bilingual classroom. It's not because the teacher is not bilingual. It's just that he chose this to be an English-only lesson. This time I'd like you to focus on the students, and in particularly, how did students use language to communicate mathematical ideas? And what math practices did students use? Listen careful again, watch Julian, you'll still have the subtitles, and I'd like to have, again, I will read the transcript after the video clip to slow it down a little bit. And again, put your responses in the chat. And to help you in the handout, I've listed my favorite 4 Common Core math practices, but I've added a bunch. There's the older names: reasoning, communicating, explaining, justifying. I don't want to forget problem solving, sense making. My favorite one is using and connecting math representations. I absolutely call that a math practice. Looking for patterns, abstracting and generalizing. And I don't want to forget imagining, because a lot of the work we do in mathematics is imagining, and that is a math practice. So you have this list in the handout. You don't have to memorize any of these. And you have the 2 questions. How did students use language? And what math practices did students use? So here's the video again.
Okay, today we are going to have a very special lesson in which, boy, you're really going to have to listen. You're going to put on your best listening ears, because I'm only going to speak English. Pick anything else, only English. Let's see how much we remembered from Monday. Hold up your rectangle high as you can. Okay, good. Now, who can describe a rectangle for me? Eric, can you describe it? Can you tell me about it?
A rectangle has two short sides and two long sides.
Two short sides and two long sides. Can somebody tell me something else about this rectangle? If somebody didn't know what it looked like, how would you say it?
Parallel.
It's parallel. Very interesting word. What does parallel mean?
Parallel.
Wow, that's a pretty different word, isn't it? Parallel. Can you describe what that is?
Never get together. No. They never get together.
Okay, what never gets together?
The parallel. When they get they go higher. They never get together. Yeah.
Interesting, isn't that? Very interesting. So that means if it's a rectangle, then the sides will never meet. Those sides will be parallel. Good word. Excellent word. Anybody else have a different?
All right, so I'm gonna jump to the transcript, joining in where Eric says a rectangle has two short sides and two long sides. And you have this in your handout as well. The teacher says two short sides and two long sides. Can somebody tell me something else about this rectangle? If somebody didn't know what it looked like, how would you say it? And Julian says, paralela. He's holding up a rectangle and his voice trails off. The teacher says, it's parallel. Very interesting word. Parallel. Wow. Pretty interesting word, isn't it? Parallel. Can you describe what that is? And Julian says, never get together. They never get together, and he's running fingers over the top side of the rectangle. What never gets together? The paralela, when they go higher, they never get together. And now he's running two fingers again, parallel along the side. And Antonio chimes in and says, yeah. Very interesting. The rectangle then has sides that will never meet. Those sides will be parallel. Good work. Excellent work. So this is your time, opportunity to put some responses in the chat. How do you see students using language? And do you see any math practices? I think some of you mentioned some things before, that there were gestures. Let's see, use language to talk to the teacher with the class listening, but they didn't have a chance to talk to each other. Somebody saying representing with fingers, so using their fingers to show two parallel lines. Students seem to feel safe enough to take risks when answering questions in the whole group. Certainly there were some norms established early on in this classroom where students were contributing and felt comfortable doing that. Use the fingers in the model to justify and further explain what parallel meant. And his partner, I think I was Antonio, was listening and adding in. Attending to precision of language regarding parallel. Several students repeated the word parallel after the teacher said it. Let's see if I don't think I missed anything. Oh, he uses everyday language about relationships, saying they don't get together. Let's see, the teacher pressed what never gets together. The first time I thought I heard many more words from the student than he actually said, because I was listening, watching for meaning. When I saw it in the transcript, I realized there weren't as many words. This is why I read transcript. It slows down the activity even more. It's a luxury we get when we look at a video to actually look at the transcript. Abstracting or maybe imagining parallel lines beyond the confines of the rectangle. Other students maybe notice that parallel is a cognate. That's a really good thing to wonder. Anything else that you'd like to share a response? All right, so one thing I'd like you to notice, the teacher provides additional language. They never meet. So I'm going to move to my analysis of this example. There's many things we could talk about here. First, I'd like you to notice, how did Julian describe a rectangle? He says that paralela, when they go higher, they never get together. And again, that's kind of the drawing of extending those lines. So what's the mathematical concept? Parallel lines, at the very least. And here's a formal definition. It's a straight lines in a plane which have no common point, no matter how far they are extended. Of course, if you've ever been in a classroom with children, you know that this is not what they're going to say. So our job is to listen and hear where are the mathematical concepts when they're expressed in their own ways. So the first recommendation is to focus on math practices, not on languages, words, vocabulary, or formal definitions. We are rarely going to hear formal definitions, and there's a really good reason why we want to focus on math practices and why we want to shift from thinking of language as vocabulary, single words, or formal definitions. An emphasis on vocabulary or formal language limits the language resources that students have for learning and that teachers have for teaching math with conceptual understanding. It can also preclude students from participating in math practices. You can imagine that if the teacher had stopped everything to correct anything, for example, the pronunciation, he did say paralela in actually a Spanish pronunciation, or to correct a single word, that really stops the participation in math practices. Instead, the teacher didn't do that, and he focused on the mathematical ideas. So sometimes it can be a challenge to hear math practices. We need a lot of practice ourselves in hearing and uncovering math practices. In this case, emerging language and ideas can be imperfect, not just for children, but even for ourselves, right? Julian's utterances are hard to hear or interpret. He hesitated when he said paralela. He mixed English and Spanish and added an a, not an a, but an a to parallel, pronouncing it in Spanish. He also used a singular word, paralela, followed by plural when they go higher. So grammatically, this isn't correct. But when language is imperfect and emerging ideas are also imperfect, we might be wondering, was this hesitation due to pronunciation, the word choice, or was it the math idea? It's really impossible to answer this question. Whether it's children or people who are bilingual, if you ask us, what does our confusion come from? Language and ideas are completely sort of wedded together like a plant. Everything comes together. There's no way for us to tell internally, and we can't really be asking students, where does this come from, the hesitation? Instead, we need to notice, as many of you did, that Julian accurately described a property of parallel lines. So if we're focusing on math practices instead of formal vocabulary, it's more important to look at the meaning of the whole utterance, not just one word, to listen for math practices, and to uncover, hear, and support and extend the math content and the math practices and what students are saying. It's less important to focus on single words or formal vocabulary. So what math practices did Julian use? I see him at least as using abstracting, generalizing, and imagining. He's describing an abstract property of parallel lines, making a generalization that parallel lines will never meet. He's also imagining what happens when the parallel sides of a rectangle are extended. If we were to focus on only formal vocabulary, we would miss those math practices. At this point, I'd like to mention one math practice that I think can get misinterpreted to mean something that we need to be careful about. So the math practice attending to precision doesn't mean precision in using the most beautiful, mathy, perfect, precise math word. It can mean many other things. Let me give you an example to illustrate that. If a student says multiplication makes an answer bigger, we could think of attend to precision as, oh, they really need to be saying the precise math word product. It's not just an answer, it's a product. But here, precision is the math practice of making the claim precise. Instead, a teacher could ask, when does multiplication make the result bigger? And then you could have a whole conversation about, well, is it multiplication by a whole number larger than 1? Or what happens it's multiplication by a whole number larger than 1 that's not 0 or not 1? That's a conversation where precision is about making the claim precise. And I think one of you mentioned that was a move that the teacher made when the teacher asks, what never gets together? Recommendation number 2 is to treat everyday and home languages as resources, not obstacles. Why do we want to do this? Because they are resources for communicating mathematical reasoning. Everyday language is a resource. I think somebody mentioned that in their response. What language resources did Julian use to communicate his mathematical ideas? He used everyday expressions. Go higher and get together. I always wonder what happens, if lines never get together, what happens if they were to get together? Do they have coffee together? Or it's a great way to think about lines getting together. So everyday language is a resource, not an obstacle. Now, what could the teacher do next? He could build on the student response. He could ask for clarification and explanation. He could use gestures and objects. He could rephrase the student statement using more formal language. And I want to really emphasize here that working on written communication is a really good way for using more formal language. Classroom discussions might not be the best place for that, but with written communication, you can have support for revising and developing more formal language. So we need to really consider the settings and the goals. What is the communication setting? If you're doing peer work, there's likely to be a lot of informal talk where students are saying this and that, and we don't really have precision in the claims. Informal presentations, you'll get a little bit more formal talk. Written work can be revised, and that's a good place for working on developing even more formal language. What are the goals for discussion? Typically, to get participation going, to express emerging mathematical reasoning, to explore ideas, and to use emerging language. Whereas the goals for written work are then to refine and revise ideas and language. And I see that I have a little bit more time, so I'm going to share with you. You've all noticed that the teacher was doing some really interesting things. I'm going to give you a summary of what I see the teacher doing in this video. First, he was building on student responses. Many of you noticed that. When Julian said paralela, the teacher said parallel. Can you describe what that is? He was also asking for clarification and explanation. When Julian said they never get together, the teacher said, what never gets together? Again, asking for precision in that claim. He was rephrasing student statements using more formal words and ways of talking, and he also made the claim even more precise. So here are the lines. Julian said they never get together. The teacher said, what never gets together? Julian says the paralela, they never get together. And the teacher rephrases that. The rectangle then has sides that will never meet. Those sides will be parallel. So to summarize, he built on the student contribution. He supported the mathematical practice, attending to the precision of a claim, and he did provide more formal words like extended and meet. There is some work that's been done in second language acquisition and in learning to use what's called academic language, that simply providing that in discussions is a good way, if you do it over and over many lessons, to support students developing more formal language. So again, the summary of the recommendations for attending to language in math classrooms and attending to equity as well as language are to focus on mathematical practices, not language as single words or vocabulary, and to treat everyday and home language as resources, not obstacles. And we are at 4:45, so I am going to thank you for your attention. I want you to know that you will receive with the recording a list of articles that are based on this lesson and a list of resources for working with multilingual learners. And we now have time for questions.
Thank you, Judit. As we continue this focus this year on truly knowing our students as math learners, this session really helped us unpack and think about what it means for math instruction to be equitable and effective, particularly for our multilingual learners. And not just theoretically, but to really think about what this looks and sounds like in a real classroom. And I feel like that's a really powerful thing to give to us. So we thank you for that and for your time. I do have a couple of questions, and if you have others, folks can send them to me in the chat. But maybe to start with, I know some of the folks on this call we are connected to sort of curriculum work. And when we talk with folks about multilingual learners or their questions about working with multilingual learners, we also often get questions about vocabulary and teaching vocabulary and this very sort of just an extreme focus on this question of vocabulary. I wonder if you could just talk about that question and sort of your response to it.
Yeah. So you may have noticed that I'm trying to shift us from focusing too much on vocabulary, in part because I think it's an intuitive way of thinking about language is that it's vocabulary. Many of us, it's sort of a folk model of what language is. What I've heard from linguists is that it's really that vocabulary is not the way that we learn language. If you think about how we learn a second language when we go to another country, we learn to interact with people. We learn to do things in another language. Vocabulary is something that happens that we learn while we're doing things. So I've asked vocabulary experts for their recommendations, and this is what I've collected from those conversations and that reading. Because again, I'm not a vocabulary expert. So how do we support vocabulary learning? First of all, carefully consider whether and how to pre-teach vocabulary. It turns out that pre-teaching vocabulary is not very useful or successful. Again, think about if you learn a second language, somebody tells you here's a list of words and here's what they mean. You walk away and you probably forget what was said to you in terms of, again, definitions. Instead, to introduce formal language after students have solved problems. They've done something. So they've done something interesting, and you introduce the formal language afterwards, while students are talking about the reasoning and using language to solve the problem. You can ask students to actively find and review vocabulary after doing an activity that grounds the meaning for words, right? They've solved a math problem, they've explained a solution. One of my favorite, what are called language of math tasks or language routine, is called Speaking Mathematically, where you ask two students to pair up, have one student speaks and the other one tallies when they hear vocabulary words that their partner is using. You can give them the list and then they can tally them. This is much more active, right? They're listening for vocabulary. One of them is using vocabulary. That's just one way. Again, the most important thing is to do it, focus on vocabulary after students have been engaged in an activity that uses that language.
Thank you for that, Judit. It reminds me of the writing I was talking to you about, where you were talking about the importance of using mathematics and language together, that they're so interwoven, which you talked about earlier too.
Yeah, yeah.
I have another comment and question from Leslie. Thank you, Dr. Moschkovich. Currently, where do you think the literature stands, and what gaps do you see that need further research regarding bilingual students?
Oh dear. Oh, let me take a deep breath. The research literature, well, where we stand is that policy needs to listen to the research literature. I think we need many more examples of what we mean by assets and strengths. We say that a lot, and then it's like, okay, what does that actually look like, right? So many more concrete, detailed examples of what those assets and what those strengths are and what they sound like. I also think it's maybe time to go back to some of the curricula that, really work with multilingual learners and document that, in fact, they do work. I don't think, either for elementary or secondary, that we have a lot of studies that, quote unquote, prove that things work. And I hesitate to say that because even when we have that data, sometimes policy people don't listen to the data, but I think it would be good to have a few more of those studies. I also think we need some research on how teachers can help students start and be grounded in everyday language and how they move to more formal language, particularly with writing. We need some research to be done in looking at how to refine language through writing. So that would be, again, very useful. That's a great question. Thank you for that.
Another thing that really came through in your talk was this idea of the importance of looking for and documenting student strengths and competencies and resources. And I wondered if you could talk a little bit about ways you see teachers do that and describe how it helps them support students with mathematics.
I think the fundamental one is knowing your students. I work mostly with adolescents, and adolescents tend to have had previous math experiences. But I think children in elementary school have previous math experiences. So knowing what the children you're working with are doing at home and outside of school, so that it isn't that we have to create a curriculum that mirrors everything that every child is doing outside of school. That's not possible. But knowing something about the community, what is the work that the parents are doing? I think of Marta Civil's work, where whatever parents are doing, whether it's games or the work that they do, the more you know about the children, what they do outside of school, the more they will connect to what's going on in the math classroom. I think it's also really important to talk and work with the parents, because many parents, as you know, will have experienced mathematics in a different way than what research says is the best way to learn mathematics. And they will come in and wonder, what's going on and why are you teaching my kids this way? So I also think of Marta Civil's work with parents to help them to see why conceptual understanding. What does that mean? What is it to have them experience mathematics that way? I would say those are two important ways to know the children and the community. And then the more I know that we can't always speak the multiple languages that are in our classroom, but learning something about what are the common language practices in different communities. So are we working with kids who have been told to be quiet and not look at adults directly? So don't assume that kids are being shy. They might just be being respectful. Are we working with kids who come? I always think of Hawaiian communities where there's something called talk story, where people interrupt each other all the time, and children will jump in and they're not being disruptive. They're doing what is expected of them at home. I know that in Spanish speaking communities, there are multiple ways that things sound different, that people might get off topic, that students again might interrupt at different times. Just to be aware of those in terms of the different communities that one might have in a classroom. And I know that there may be more than one language, so it's not about learning everything about every community, but enough to know, oh, what's a comfortable way for these students to participate, and to just not assume that silence means not participating and not understanding. I want to really raise that up, that silent children may be paying really good attention. I've actually written a paper about that. There was a student who was being very quiet. One student was talking all the time, but the student who was quiet chimed in at the right time with a very good mathematical idea. He'd been paying attention the whole time. That was a great question. Thank you.
It's an interesting connection to some of the work the forum's been doing to think about sort of, so what does participation mean? And it doesn't have to mean either just speaking or speaking in a particular way. That things like gesture and body language and turn and talks, and that there's lots of different ways that we can honor kids' participation. And it makes me think a bit about beliefs too, of, if I really believe a kid is trying to make sense, then what they're saying makes sense to them. And so how do I frame it that way for myself and for that child, right? That strength.
I think the field of math education, we work so much on mathematical discussions that we maybe are responsible for focusing on talk. So we need to say, wait, it's not only talk, drawing, there's lots of ways to participate, and that being quiet is not a bad thing. And that also, the loudest, most confident voice isn't always the most mathematically accurate or the most mathematically interesting voice. So yes, going beyond participation as talk is really important, which is why we've been trying to bring writing back in. It may be a way for some students to participate. Usually, again, some of the ways that people respond, oh, no, but students who are learning English can't write, right? It's true that social talk comes first and oral communication comes first. That's absolutely true. But we're in a classroom, and again, we'll have to think more about how to work with ways of communicating through writing. Because if you think about talk, you say it and it disappears. It's hard to refine it. If you write it, you can work with a peer or a teacher and say, oh, I could make this better and different. There's opportunity to refine it because it's written down. A drawing is the same thing. You can refine a drawing, but talk is gone.
It links me back to the idea of representations being important and manipulatives, and the kids having that rectangle and being able to draw the lines that extend from the rectangle were an important piece. It wasn't just out there in the ether, that he had something to look at and refer to. We're at 7:58, so I'm gonna, if you can do this one quick, take it, and if not, we'll sign off. And wow. So there was some curiosity about, you said something about sort of having some of the math practices of the Common Core that you weren't so thrilled with. And I wonder, you talked a little bit about to tend to precision, and that's where my mind went with multilingual learners, is people thinking that means sort of vocabulary. Is there anything else you want to say about that?
Yes, it was definitely limiting attention to precision to be the most mathy word. The other one that I'm not so happy with is using tools, because it's so vague that it could be anything. And I also think just 8 things is too much to remember. That's why I've tried to collapse them. I also feel that we've done a disservice to all the work that was done before in the NCTM standards with problem solving and persevering. They were all there. So I don't want people to think that these are new, right? Or that they came out of somebody's head. They didn't. We've been doing research on math practices before the Common Core, and we were working with those math practices. It's more about putting that label on them. These are math practices. So I encourage people to, take the ones that they resonate with, reduce them, and also don't think that every lesson has to cover or include every single math practice.
All right, we are right at 8, so I'm just going to finish us up here. We wanted to thank everyone so much for coming, and thank Judit for sharing all your expertise and these decades of research and ideas about effective practices with us tonight. And to let people know that the last session of our year is going to take place on April 29th. We are so thrilled that Running Horse Livingston is going to be talking with us about math identities and how they matter, how you can cultivate belonging and community in elementary classrooms and why that's important. And we just wanted to give that last slide around the Forum for Equity in Elementary Mathematics. This QR code will take you there. We encourage you to take a spin and see what's there. There's lots of resources and tools. The recording of the session will be posted there in the next few days, and you will get an email pointing you to that recording and also to the resources that Judit compiled for us, which we're really thankful to have. So thank you so much for coming. Thank you, Judit. What a wonderful session. And we hope to see you in April.